Ever looked up at the sky and wondered what's protecting us from the vast chaotic cosmos? For a long time, we thought we had a pretty good handle on it. It is wrapped in a giant magnetic bubble called the magnetosphere. Think of it as our planet's personal bodyguard, deflecting a constant stream of charged particles from the sun, known as the solar wind. This cosmic shield is what makes life on Earth possible. When the solar wind slams into our magnetic field, it's like a cosmic collision that sets up powerful electric ants. This interaction is the engine behind what we call space weather. It's responsible for the breathtaking beauty of the auroras. But it can also be incredibly destructive, capable of knocking out satellites, disrupting power grids, and scrambling our communication systems. Understanding how this system works isn't just academic, it's crucial for protecting our modern tech-dependent world for decades. The scientific model of our magnetosphere's electrical system seems straightforward. Imagine a spinning with a morning ordon side and an evening ordon side. The long-standing theory was that the morning side held a positive charge and the evening side held a negative charge. It makes sense, right? Electric fields typically push charged particles from positive to negative. It was a neat, tidy picture that explained a lot. But as we're learning more and more about our universe, we often find that things are far more complex and fascinating than we first imagined. And recently, scientists have uncovered something that turns these decades those model on its head. A team of researchers led by Professor Yusuke Ebiara from Kyoto University has made a groundbreaking discovery using fresh data from satellites and advanced computer simulations. They found that our planet's electric heartbeat is, in part, flowing in the complete opposite direction of what we've always believed. Their findings show that the morning side of the magnetosphere actually carries a negative charge, while the evening side is positive. It is like finding out the northern south poles of a verti was swapped in a major part of the second diagram we've been using for years. So, how did they figure this out? The team dug into data from a very special NASA mission called the Magnetospheric Multiscale, or MMS. This mission is designed to study a process called magnetic reconnection. This is where the sun's magnetic field and this magnetic field connect, break, and then reconnect, explosively releasing huge amounts of solar energy into our needless space. This is a very process that fuels simple space weather events like geomagnetic storms and those vibrant auroras. Analyzing this high-resolution data, the scientists got a never-before-seen look at the electrical dynamics at play. To double-check their findings, they also ran incredibly detailed computer simulations. They created a virtual Earth and blasted it with a steady stream of simulated solar wind. The results from these simulations matched what satellites were seen in real life. They confirmed that while the areas over our planet's poles behave as expected, the regions near the equator are completely reversed. The charge patterns are literally upside down compared to those models. This discovery raised a huge question. Professor Ebiara put it perfectly in the conventional theory. The charge polarity in the equatorial plane and above the polar regions should be the same. So why were there in opposite polarities between these two regions? It's a puzzle that challenges the very foundation of how we understand energy flow around our planet. Since it turns out lies not in static electric charges just sitting there, but in the dynamic movement of plasma. Plasma is a superheated state of matter, a soup of charged particles. And it's what the solar wind is made of. When all the energy from the sun hits our magnetic field, it doesn't just bounce off. It causes this plasma to get caught up and swell around our planet in massive cans. Here's where it gets really interesting. On the dashboard corresponding side of Earth, this plasma flows in a clockwise direction, moving away from the equator and towards the poles. At the same time, you have some magnetic field lines, which jump out from the southern hemisphere and connect back in the northern hemisphere. Near the equator, these field lines point generally upward, but near the poles, they point downward. So, you have two opposing forces. The plasma is flowing in one direction, while the magnetic field lines are oriented in the opposite direction. It is this complex interaction, this cosmic dance, that fundamentally changes how electric charge builds up It's not about a simple positive to negative push. Instead, the motion of the plasma itself is what generates the distribution of electric charges. As Professor Viara explained, the electric force and the charge distribution are both the result of the plasma's motion, not the cause of it. This is a major paradigm shift, by showing that different parts of our magnetosphere can behave in opposite ways. This study adds a critical layer of nuance to our models. It refines our understanding of how energy from the sun is captured and channeled into Earth's atmosphere. These improved models are vital. They could lead to much more accurate space weather forecasting, giving us the advanced warning we need to protect our vital infrastructure from the satellites that power our GPS and communications to the power grids that light up our cities. And the implications of this discovery don't stop at Earth, other planets in our solar system, like the gas giants Jupiter and Saturn, have massive magnetospheres of their own. They also interact with a solar wind in similar, though much more powerful ways. Understanding the reverse electrical flow around Earth could provide a new lens through which to study the magnetic environments of these other worlds, helping us unravel the mysteries of their own unique space weather systems. What this incredible research shows us is that even our own cosmic backyard is full of surprises. Just when we think we have it all figured out, a new discovery comes along that deepens our understanding and opens up a whole new set of questions. It's a powerful reminder that science is a journey of constant discovery, and there is always more to learn about the invisible forces that shape our world and the universe beyond. Thanks for joining us and this deep dive into this magnetic mystery. If you found this fascinating, don't forget to like this video, subscribe to the channel, and hit that notification bell so you won't miss our next exploration into the wonders of space. See you next time.